Hello, everyone. My name is Zona Kostic, and I will present the paper that focuses on hand-midair interaction in data visualization. So why this group of authors is interested in exploring midair-hand interaction in data visualization? One of the reasons is that interacting with remote visualizations, for example, with remote displays, necessitates the use of instruments. And usually interacting without instruments is characterized with midair gestures. While midair gestures are considered intuitive, they also lack precision and they need different ways of expressing data-related intentions. Here, I'm just going to give a very short overview of where can we use midair gestures. Our research focuses on 3 different studies: the elicitation study, user study, and expert study. The overview of the studies, I know that this is not typical how we do the presentation of the study, but I'm just focusing on the really important aspects. In all 3 studies, we have 52 participants, and they were all of age between 19 and 60 years old. Important to mention is that we run all the studies via Zoom. The first study, elicitation study, is aiming to help us design to help us define the design space for midair-hand interactions with data visualizations. Here we have the example of one participant suggesting the gesture, giving the visualization. We used multiple different visualization encodings and different operations. We also tend to use same operations across different data visualizations. So after running 15 different tasks and then different questions where we ask people, what gesture would you use if you were about to rotate pie chart, for example? We calculated agreement rates. Some of the tasks are with a higher agreement rate, some of them are with a lower. As a result of the elicitation study is also something that we call intention effect map. The actual color coding here stands for different gesture types. Gesture types are different classification of gestures into sort of gesture types groups based on the physical characteristics. And what we can notice here is that, yes, some tasks are with a higher agreement rate, some of them are with a lower agreement rate. But if we look at the actual colors, which are pointing to the different gesture types, we can indicate that despite different gesture suggestions, all of those suggestions tend to fall into the same gesture type group. Interesting discovery was also that for certain tasks, participants tend to propose consecutive gestures, executed one after the other. And then when we asked them, well, can you see those gestures as implemented or actually performed as a bimanual gestures? Most of them said no. And this is interesting because in the user study, we're sort of going to prove the opposite. Also, one additional discovery that we also previously mentioned is the big influence, the impact of data visualization to gesture elicitation. Here we have the example of using exactly the same operation for fairly 2 similar visualizations, such as pie chart and donut chart, but those 2 elicited different gestures that are also not into the same gesture type group. And the reason for it is that donut chart is basically the hole that is in the donut chart is perceived as non-interaction area. For the tasks where we elicited really low agreement rates, we tend to use gesture topics or gesture themes. It's been indicated and it's been sort of noticed that participants can perform many different gestures. Those gestures can fall into the same gesture type group, but they also tend to sort of exhibit the same topic, how users tend to interact with the data. So there is one topic that can be extracted across a variety of different gestures, which is really suitable technique in cases where agreement rates were extremely low. After the elicitation study, as we mentioned, we focused on sort of collecting all of the challenges and insights and designing the actually defining the design space dimensions. In the subsequent user and expert studies, we tend to evaluate the effectiveness of our design gestures. A user study, we focus on the learnability and the memorability of design gestures, emphasizing agreement rates. So whenever we wanted to design gesture, if the agreement rate for that specific gesture or specific sort of task operation was high, we designed that gesture as elicited. In every other case, which was actually more interesting aspect of the paper, is how to tackle and design gestures with very low agreement rates using intention effect mapping, but also try to address some other challenges that were discovered during pilot study and also later on during user study, is how we can tackle some how can I put this, trade-off between disambiguation and input mapping, but I'm going to talk about it later. So we designed 8 gestures. Most of the names of those gestures are familiar to you. Some of the novel gestures are Z-Pan, which is emphasizes 3D interaction space to access the layers of data, as this was said by one of our participants in the user study. And we also use zoom and drag as some sort of hybrid gesture, which actually combines two operations into the same gesture. After the tutorial, participants were prompted to the user study when we asked them 9 different questions, and we actually measured recall. The most interesting aspect that none of these questions are focusing on gestures. None of them are mentioning the name of the gesture, nor recalling the name of the gesture was important. We asked data visualization related questions, such as select a data point for a country from sub-Saharan Africa, and we wanted to see what would be the intuitive first gesture that users would sort of show. We also, during user study, we sort of tested for bimanual manipulation, and none of the users had issues performing any of the bimanual tasks. Expert study is all about the trade-off between memorability and comfort for design gestures. We evaluate the effectiveness of our design gestures by focusing on ergonomics evaluated by subject matter experts. The gesture with the lowest recall sort of has the highest ergonomics ratings because of a really comfortable posture, muscle strain, and wrist movement. Of course, all of the other gestures were also evaluated based on the same criteria. At the end of the paper, we are suggesting, we are sort of emphasizing the design and mid-air hand gesture design considerations. First and foremost, I'll really try to be short, but first and foremost, there is this desire for rules and disambiguation, and the need for the trade-off sort of between input mapping and disambiguation. Appropriateness is a really big and important factor. Gestures should be designed and tailored to the specific purpose of the application. So if you're creating something that needs to be discovered by the general audience, focus on legacy bias. People will be able to draw gestures from sort of previous experiences with other interaction modalities. But if you have the need for creating a completely novel interface, we hope that intention effect mapping would be of use for you. Disambiguation, so like basically gestures are less discrete compared to WIMP interfaces, for example. but disambiguation can also mean you can keep the same posture, but just change the direction of translation. Input mapping sort of focuses on the number of the gestures, so users need to differentiate and have a gesture for different operation, but we also need to sort of lower down the scope of gestures. There are some sort of aspects, and there are some considerations and recommendations in the paper that also focus on sort of this type of trade-off. Accessibility and ergonomics, we always already focused about it. And last but not least is the embodiment, which is the actual perception of the users when it comes to the technology of being the extension of themselves. The embodiment is really suitable to address challenges with input reliability, because we can use the iconic gestures to highlight different parts of visualization and then be able to give the indication to the users of our applications what is the gesture that they should use, and when the actual when the application is reacting to their input. A visual feedback can subtly alert, in this case, about users when their postures and gestures are becoming ambiguous, and they can actually be used to guide their interaction. I know that we are sort of running out of time. There are many interesting aspects and many interesting sort of experiences and then stories that we can share when it comes to all three studies. So if you have any more questions or you would like to chat more, feel free to reach out. I'm open for any discussion when it comes to utilizing mid-air gestures for data visualization. Thank you.